Today we are going to present the HICU this paper, and Yuanpei will take over now.
Hi, welcome to our demonstration on hierarchical curriculum learning, or HICU, a pioneering algorithm designed to revolutionize the field of automated IC decoding. So HICU addresses a fundamental challenge in IC decoding, the accurate prediction of codes, especially the rare ones. The key innovation of HICU is its use of depth-wise decomposition of the label graph, coupled with a hyperbolic embedding-based knowledge transfer. So in terms of the scope of reproducibility of our project, we are able to reproduce all the results and all those four hypotheses that the author of the paper mentioned in. Let's go to the methodology. In order to run the program, you need to install all those packages on Google Colab, and you need also to then download data, follow the following instructions. You need to place the MIC3 into the data folder. The model part, here is the citation to the original paper, and here's the original GitHub repo. The overview, the model is built upon a hierarchical curriculum learning framework that integrates with various neural network architectures, including RNN, CNN, and the transformer. Basically, this is encoder-decoder architecture. The encoder has 3 P's, and by LSTM, multi-res CNN, and the rec reader. The decoder is just a per label attention mechanisms. And we tested different loss functions, such as the original BCE loss or asymmetric loss, which is called ASL loss. For optimizer, we're using an Adam optimizer. Now, Jiachun will talk about the hyperparameter.
Oh, yes. So in the hyperparameter part, we actually change the batch size and also the learning rate and the dropout. So we basically did this in our Python class, and I'm going to share the screen right here. So as you can see, we copied the model, and there is the utils, and the utils has an option. And in the option part, we are able to change the dropout, and also the dropout will be reflected whenever we run the model. And we also have the learning rate, as we mentioned right here, and also the batch size. We made some hyperparameter change, fine-tuning, and Renpei will take back.
Yeah, thanks, Jiachun. So for all those training codes, evaluation codes, evaluation matrix, we're using the AUC, F1 score, and precision. So all those codes, evaluation codes, they can be found on the GitHub link. And here's the results. Detailed result can be found in the results folder. And I'll talk about the ablation study on the loss functions. In our project, we proposed the novelty loss function. This is not introduced in the original paper. It is called a dice loss. We're trying to use the dice loss to handle the imbalanced data. And here's the results for the ablation study. In this study, the ASL loss outperformed both BCE loss and dice loss. So dice loss is the worst in this case because the underperformance may seem to because of the insensitivity to the label imbalance, and it's hard to tune the smooth parameter. So now let's take a look at how to run the code. In runs, we have multiple Python files, like Python runs/run multi-res and HICUC50.py, and that's it. So please make sure you install all the Python dependencies and using Python 3.11.
Yeah, so we also set up the environment from the Colab, so you can easily run our code from the Colab. And we remember, whenever you run the model, the different model, and just do the pre-process for the data, we also put it over there. Thanks. I think as you can see right here, the code is running, and that's our presentation. And